Tianjin University of Technology, PR, China, Principal Investigator of the Biometrics and Intelligent Systems Group, he was a visiting research scientist in the Center for Robotic Research at the University of Cincinnati. He also held a young researcher position in the Finnish Academy. He was nominated as Fellow of SPIE. He has 3 patents and has published more than 400 papers in the areas of computer vision, robotics, intelligent signal analysis, and software security. He was the academic coordinator for DIMECC Cyber Trust Program and the project coordinator for H2O, 2020 High Flyers and CS Aware projects. He's currently the project coordinator of CS Aware Next project and currently serving as a board of director for euRobotics and vice president research. Please welcome Professor Juha Ronning on stage.
Can I use my own computer or?
I think it has been work a presentation then. I think it's linked to stage.
Very good.
Would you be comfortable with the podium light?
Yeah.
Or would you need a cordless? It's one here.
I think so. Thank you. Is this on? Very, very good. First of all, thank you very much from the organization side inviting me this Nepal event. It's my pleasure to be here. It's the first time in Nepal, and I was already enjoying when I was arriving here from the airplane, the great views and the great place you have here. It's very good experience from my side. Also, I would like to thank very wise and mature words of Prime Minister Sharma Oli. I was very interested to listen your thoughts, and I'm quite convinced that your thoughts are in a good way for the digitalization of Nepal. Also, I would like to thank my special thanks to Bikash Gurung inviting me here, and we have had very good discussions earlier, and at the end I would like to also perhaps invite him to be and be our guest in the coming event. Unfortunately, I'm not that well prepared in the sense of supporting all the travels and things which are extraordinary, but what have been happened to me from your side. So your kindness, friendliness is overwhelming, and my big thanks on that. I have a couple incidents which I want to share with you, and I will start with these and repeat them at the end. In Europe, we are now considering, and I mean really considering, what is our position on AI. Surely the Commission already announced a couple of years ago, when the new framework was prepared, that AI will be very big and actually overwhelming everything. This is fine, but still we have to acknowledge the current situation that AI, the model, the models which we can use or which are available for use are developed by global companies. And there is a danger which we need to challenge. So one of the things which I want to share with you, which is also concerned how the AI can be used and should be used in Nepal for the future, is that there has to be this ethical angle and responsible attitude. And I'm bringing in this talk some thoughts about regulation, perhaps even the standards, so that we need to have this kind of global rules so that we can use it and the AI in a good ways and practices which we have acknowledged. And that way we can work together and also help the future of Nepal country. The other thing which I want to bring you that from my thoughts, and I will put it in simple way, AI does not do anything. AI is good tool, but to make it as a good tool, you have to understand where you are applying it. Therefore, all the youngsters, listen carefully. You have to learn your stuff. You have to be expertise on your area. And then, and only then, you can use AI in a good way so that you understand what it is proposing. It's very good tool, wonderful tool, but you have to have your knowledge to use it in a good ways. Those are the two things which I would want to share you with this talk. But then I'm euRobotics, so I'm there as a vice president on research, and with this capacity, I'll first introduce what kind of association we are. So we are the largest network of robotics and business in Europe, 250 member organizations. So we don't accept individual members. We have been existing 20 years and been able to create a strong connection between research organization, industry, and wider ecosystem. The engine, how we work, is the grassroots groups, which are covering robotic-related themes, including perception, mechatronics, AI, cognition, and etc. That way, we have been able to harness all the expertise which we have in Europe. We manage also a range of European scale events and regular meetings. And we need to collaborate in European level. So we have very strong links to European and national policymakers. Here are some examples of the events which we are organizing. So we have a European Robotics League, which is a series of competitions. That way we like to raise the awareness, exploring alternative approaches, and surely also having fun. Robotic research is fun, so I enjoy it and have been enjoying all my life. We are also now heading European Robotics Week. Actually, I'm traveling in 2 weeks in Zaragoza, where we have large meetings on that part. And our flagship event is European Robotic Forum. We arrange it annually. Next year, it will be in Stuttgart, Germany, 25th to 27th of March. Last year, we had already 1,100 participants on that. And this is not a scientific conference. It's a networking conference. And this is what I think is very important. You can do a deep research, getting good knowledge, which can be shared. But you have to connect that knowledge with the companies who can make the products and make it work in a good way. And in these events, I am representing the science part, the research part, but there are big companies, smaller companies, and all the enterprises together, and we have normally 3-4 days discussions how to do the future in a good way. So then to the moral of this story. So if we look back, what does a robotics mean nowadays? Surely it is a science of integration. And now comes the strong risk which we have if we just rely that AI will do everything. Most of the components which we have are not related in AI in robotics. We have mechanism, drivers, gears, power supply, low-level controllers, sensors, external control systems, safety components, user interfaces, and so on. So more and more are AI-driven. That's fine. And we have applications which are using AI in some functions. But we have to understand what the AI is doing. It is not just a black box which solves everything. So AI is mainly used as an application level, but on the hardware and its relating components not. Some components such as safety cameras may be used AI in the future and also today, but that has to be safe and fully certifiable so that we understand what we are doing. We have path planning, we have control, we have sensor integration. I think that we still need quite strong development and research when we are using the components to tame the combination of hardware and software. So what is ongoing now and what are the challenges on robotics? And now I am talking with European voice. We, as what I am representing, are saying that AI is made in Europe. And when it is made in Europe, it is made for robotics. So from my point of view, the modern systems and software architectures are far away from plug and play. We create programs and quite often they have mistakes, flaws, errors, bugs, and that can cause a lot of problem. If there is heavy machine and a bug in your software, it's a very risky combination. So we have AI and still very massive initiatives ongoing. We want to have safe, trustworthy machines. And that's the why we need to understand what we need to standardize so that all the parts are efficient, interoperable, safe, and secure to be used. A lot of testing, proofing are needed. And there I see a lot of work to be done. And the only way to do this in a good way is to start collaborate. So, answer how to ensure that AI-powered robots work in European way. We can look a little bit back. So in automotive, in the early days when it was developed, every car was different. Every part, every component was different. And if you needed a spare part, they really didn't fit together. So now we have totally different. All over the market players from the world, they can use different parts and be sure that they will fit together. Why that is, there are regulations, rules, standards, which says how to use them together. So the need in the hardware level was pushed forward to the software and AI. That's the way I think it should be done. So I see that the development in the automotive sector could be the blueprint for the robotic sector. So how to ensure that AI-powered robots work in European way? First, we need to address the requirements. Legislation, we have them in Europe. We have AI Act, we have Data Act, we have even AI Office now arranged by the Commission. Technical regulations, machinery regulations, Surely we have also the healthcare part, which was mentioned earlier in the discussion. And we don't, and we shouldn't ever forget cybersecurity, usability, acceptance. Otherwise, you can't reach any market, or you can not survive in any market. So if we follow these, this could help to speed up the development of a global robotic ecosystem that can then open for new approaches and all sorts of companies. And this is what I urge also Nepal to join and just to start working together. I don't want that these global companies will rule our future. So what is needed in the future? From technical side, there are many AI technologies which are not yet ready to deal with the real world. So I think that significant research is needed to ensure that AI can be used in that context. There are many things which are potential areas for optimization, for example, in different levels, user interfaces, AI for improving the components, and so on. From the economic side, we need development on common rules. Could be standards, so that we can more easily integrate and make the parts interoperable. We also need to develop a supply chain and an ecosystem for companies of all sizes globally, and that way we can work together. So to conclude my talk, we as the global robotic community need to bring ability to integrate and use AI into all components and systems parts. We have to understand what we are doing. So the moral of the story is that we need to understand how we are using the AI in our robotic system. This understanding can come if you have your good knowledge, expertise on the area where you are applying the AI. If you apply AI as a black box and it is controlling a big hardware, you might be in danger. So that's the message I want to bring you. And then back to the invitation to here, I would like to invite your representatives, especially your president on Robotics Society, because if possible, to come and see ERF 2025, where we have our own annual meeting. It has been my pleasure to be here and to talk with you. Thank you.
Thank you so much, Professor Juha, for your keynote speech on role of robotics and AI in transforming European economies and learnings for Nepal. Thank you so much for being with us as well. अब हामी लाग्दैछौँ अर्को keynote speaker तर्फ, and the topic is robotics and AI for global prosperity and industry automation. र यसका लागि म यहाँ the director of the JC STEM Lab of Robotics for Soft Materials, chair professor of Robotic Systems, University of Hong Kong, बाट speaker हुनुहुन्छ. He received the BS, MS and PhD degrees from the Tokyo Institute of Technology and worked at Denso Company Limited. After serving as a research associate at Tokyo Institute of Technology and associate professor at Nagoya University, he joined Tohoku University as a professor. He served as distinguished professor of Tohoku University and also joined the University of Hong Kong as chair professor. He served as science advisor, Research Promotion Bureau, Ministry of Education, Culture, Sports, Science and Technology, Japan, senior program officer, JSPS, and selected fellow, Center for Research and Development Strategy, JST. He is a IEEE Life Fellow, GSME Fellow, SICE Fellow, RSJ Fellow, JSAE Fellow, and a member of Engineering of Academy Japan. He received the Medal of Honor, medal with purple ribbon from the government of Japan in 2018. It's an honor to have with us the IEEE 2020 Vice President for Technical Activities Professor of Robotics System, University of Hong Kong. Please welcome Professor Kazuhiro Kosuge.
Thank you very much. It's my great honor and pleasure to be here to give a talk about robotics and AI for global prosperity and industrial automation. Okay, I hope clicker works. I was expecting to operate my PC here, but they don't have a clicker. Okay, let me start with the AI and robotics. Okay, sometimes AI and robotics is told as science and systems, right? Science is curiosity driven. Whenever we do some scientific research, we do that because we are interested in that. Science is curiosity driven. Systems are goal driven and designed and created for specific services by integrating different technologies, hardware and software. So these two, science and the systems, are completely different, but the AI and the robotics has both, characters. Especially robotic systems, as the previous speaker you have mentioned, have a physical interaction with the environment. We have a body, robot has a body, robot has a physical interaction with the environment. So that is a more important part when we are talking about robotics. And another one very important thing is that we have no reason to develop an AI and robotic system if the system has no societal values. Okay, since we are going to artificially create some system, it has to be good for human being. So that is a message I would like to say at the beginning. And when I was many years ago, about 15 years ago, when I was working with the Japan Science Technology Agency, I had an opportunity to chair one workshop in which we are talking about how the societal robotics research at the time is related to the societal value. I asked them, what is the societal value? They say that for individuals, quality of life. For communities, industrial competitiveness. For the globe, global issues. So we discussed how the robotics foundations, AI is the same, could contribute to society through many examples. At that time, we have a lot of foundational research, robotics research going on, but we have no idea how to connect, how to link this foundational research to societal values. After a lot of discussions, we came to the conclusion that robotics can provide services, and through the service, the robotics technology, robotics research can contribute to the societal value. That is a discussion at the time. Now this year, JST again went back. We visited this topic, and they are talking about what is the current issue relating to the robotics and AI. And at that time, we found that we have so many services which we can create using robotics research. AI is the same, like a global level, environmental monitoring, natural resource exploration and development, space exploration, deep undersea and underground exploration, anti-terrorism, rescue operation, prevention of infectious disease, and the government level. These are coming from our GDP list. Okay, so you may be familiar with that. Actually, robotics technology can contribute to the government service. AI also, agriculture, forestry, fishery, mining, everything. And concerned with the quality of life, you are talking about the healthcare, right? And we discussed a lot. This is the items which we found at that time. Now we may have more applications in the quality of life. Thus, we have a lot of applications. Future, I gotta say, good things. For robots, and so that we can what I say, yeah, so that the government is a reason to fund our research and development. And this is another one. Suppose that, I mean, we'd like to have an elderly care robot, for example. At that time, we are discussing a lot. And maybe what we like, the robot is a system. So we are trying to collect the different technologies from existing technologies. But sometimes we don't have, what I say, necessary technologies, and we need, so that we need to develop. Or sometimes existing technology may not be enough, so that we have to do research to enhance the existing technologies. In addition to that, we need some technology which is specific in this field. By through those research results, we can create a robotics research. Another more important item is that whenever we develop a new system, it has to be sustainable as a business. Otherwise, just research and development and curiosity-driven research are carried out. So sustainability as a business is also very important. So I also, of course, when I was young, I'm interested in a lot of things. I thought that a robot can do something for human being. And we developed such a naive systems which can carry a large and heavy object together with humans. But sooner or later, we found that some simple tasks which could not be done by a human, humans could be done with assistive robot helpers. But unfortunately, general tasks could not be done easily, even with the assistive robot systems, because the robot does not know how to collaborate with a human. Okay, so in order to collaborate with the human, the robot has to know the task, what kind of task it's doing, its user's intention, what he or she would like to do, and how the user wants to be assisted. Actually, a lot of informations are missing. Okay, so we decided to develop a dance partner robot for developing a mechanism for closer human-robot coordination and interaction. And what we did during this development is, So the key technology is how to read its partner's lead. This is a kind of a human's intention, right? Estimation was the issue. So we developed a robot. I hope it works. And we had a demonstration in Aichi Expo. It's 2005, long time ago. Okay. So this was taken by the older video. Resolution is not so good, but this is a female dance partner robot. And I couldn't dance by myself. In ballroom dance, male dancer leads the dance. So female dancer lead, it's male dancer's lead. So that is a technology which we developed. And after that, I had an opportunity to visit the company, and many people are working like this. Okay, I thought that this worker is just working around the under the vehicle. So I found that maybe we can, if a robot could provide a worker with necessary parts and tools when he or she needs them, the worker could concentrate on the necessary and the disassembly task. So we decided to develop a robot called Paddy. And Paddy is a robot which delivers necessary parts and tools to a worker when he or she needs them, to reduce the worker's load, to improve the efficiency of the work, to prevent mistakes of the work. And again, similar to the previous case, in order to help the worker, the robot has to know the task, the worker's intention, including the worker's behavior, and how the worker wants to be assisted and so on. A lot of information is needed. Eventually, we developed a prototype system, and we bravely brought it into the actual factory, car factory, okay? And it turns out that by introducing this robot, they can reduce the working time of the worker or 20 to 30%. So they are so excited. So finally, we made it. finally, the system, a little bit after the little bit modification, was installed in the factory. This is a sensor which detects the worker's position, and the robot now we change the control algorithm so that the worker can work, more smoothly. And this is our parts supply system for the robot. And after that, we still continuing the research. And by implementing today's machine learning scheme, without getting the data in advance, we can utilize this robot. That is a recent version. So I would like to explain what I am doing now, what I'm interested in, what I'm doing now. I'm interested in robotics and automation for garment production now. Let me explain why I'm interested in the garment production. You may know the global revenue in apparel market is expected to reach $2 trillion in year 2028. This is amazing. But unfortunately, this is five biggest users of industrial robots in 2019. China is the largest user, and they installed about 11,000 units per year in the year 2019. But only 157 robots are used for textiles. In Japan, among around less than 50,000 installations, only 13 robots are used for the textiles. Other countries are 0 at the time, year 2019. But going back to the textile apparel assembly, garment industries, actually, the 80% of total production time cost in apparel assembly is used for material handling. Okay, material handling is a field where that industrial robot is supposed to be used. Why we couldn't use it? But unfortunately, this is not so easy to handle. And again, another one is sewing is the most labor-intensive process in garment manufacturing. Actually, 67% of labor distribution is used for sewing. So we came to the conclusion that we have no reason to hesitate to get into this field. Okay, as you may know, you may not know, this is before I was born, unfortunately. In 1946, ENIAC, the world's first electric digital computer, was unveiled, right? And the same year, George Devol developed the magnetic controller playback device for factory automation. And in 1954, George Devol designed a programmable robot for universal automation. And its patent was granted in 1961. And industrial robots have been brought into the market since around 1960, 1961. Okay, but this time, okay, this is a original idea is a programmable robot for universal automation. So he carefully designed a robot. You can Google the original patent. And that is to control the object of some rigid object position and orientation by programming the motion of the robot. But if you'd like to control the fabric, for example, fabric shape is not fixed. So it's very difficult to control this flexible fabric, a flexible object. That's the reason why you have some difficulties to do that. And actually, in many, today's industrial robots has a lot of still many manufacturing processes exist, which are difficult to automate using robots. And the garment industry, the handling of the garment is one of them. As you know, garment production is, consists of a lot of difficult processes. And of course, in 1980s and 1990s in UK, there are several works carried out regarding the how to automate the garment production. And some of the concepts have been utilized in the semi-automated garment production robot system in these days. Okay, so the next one is I'm going to show you what kind of result we have done so far. Most recent version. For, as I mentioned, usually, in the garment production process, several layers of fabric are cut together. So we need to separate it one by one. So for that purpose, we developed a very simple system. This is a passive actuator-less gripper. We call it PAL gripper. Is a passive actuator-less means no actuator is installed inside. So the relative motion between the finger and this housing causes a motion of close and open of the fabric. And we can pick up one by one from the stack of the fabric. Okay, next one is another one. Sometimes we need to precisely position the fabric. Like this is a color part, and this is interlining, usually used for the color. So in this case, we design different types of, and you may feel that this is easy, but okay, if I'm picking up the top fabric, several fabrics are stuck together. So the robot has to know where is the first topmost fabric is located. So for vision system, we are using AI scheme. And concerned with sewing, this is a sewing system currently used in many manufacturers, many factories. This is called a pattern sewer. So in order to sew the flexible fabric, they have to using a template, they make it solid. And by controlling the motion of this plate, sewing is realized. So we decided to do a fixture-free 2D sewing. We wanted to make something so that we can sew two fabrics together without using fixtures. Okay, this is first one is if the sewing line can be printed on the fabric, top fabric, the system can follow the top fabric so that stitching can be done without using fixtures. Another one is in this case, a sewing line or desired seam is defined relative to the outer edge of the fabric. So in this case, we are just using only the head of the sewing machine. First, next one is more interesting. Looks like we designed something for the existing sewing system, and this is unpublished most recent results. You will see, and of course, we have a vision system, we have a robot system in coordination, and through which we can sew two pieces of fabric together. Actually, this is a color part, and so that, okay. Yeah, my PhD student recently developed this one, so I thought one more slide and one more videos. I hope it will be more interesting. This is for 2D sewing. Another one is a 3D sewing. Sometimes we'd like to create 3D shape, right? The 3D shape can be created by sewing upper fabric and lower fabric along a different sewing line. This is a conceptual model, and this is really good. Let's see. Now this is a real time, so no speed up. This is no fake. This is real. And actually, this is a kind of a fabric of the car seat. And you will see that I would like to fast forward, but I couldn't operate my computer, so it takes a bit time, sorry. Because this machine doesn't have an automatic thread cutting system, so we have to do that. So this is the most recent version of our fixture-free 3D sewing. Okay, conclusion. Current AI cannot provide a complete solution for robots for real-world challenges. Of course, current robot hardware does not provide sufficient dexterity for real-world challenges. But what is important, as the previous speaker mentioned, AI is a valuable tool for robot applications that address real-world challenges that traditional methods cannot solve. I'm sure that the AI will enable the difficult task of handling the soft materials, in this case fabrics, for future garment manufacturing automation. Thank you very much for your kind attention. Thank you very much.